Right, so before the break, we went over the four cases and how it's used if it's how to solve the triangle if there are two solutions. Okay, so in your homework, I think there will be two questions. I'm not sure. I think it was two questions for today. Okay, today's homework, you will have two questions that has two solutions. Okay, so make sure you go over how to do this. Okay, you can rewatch the video again, look over the notes, and then before you start. Okay, all right, so everything up to now, okay, the ambiguous case is for acute triangle. Acute means all the angles are less than 90 degrees. Right? So you can see the question that we have here, right? All the question on the left on page 11, the angle that they give you is always less than 90, right? 60 degree, right? 34 degree, 19 degree, right? For all the questions. So what happened to the picture if it's an obtuse, okay? So that's what we're gonna do. For obtuse triangle, you can also get ambiguous. So let's write this down. Okay, obtuse means when the angles is in between, right? Between 0 degree, 90 degree, right? Bigger than 90, and then smaller than 180 degree. Okay, so between 90 to 180. So for example, like 100 degree, right? And because it's ambiguous, ambiguous means you are given an S. Oops, S. That means you have to think more. So let's look at the definition here, right? Given two sides and a non-included angle means the angle is not in between the sides, okay? So S, right? This one. So they give you this angle, I'll highlight it. They give you angle A, give you the side, hypotenuse, right? This time the hypotenuse on the opener wider, right? And then a door. Okay, so the angle A here, this one is the one that's obtuse. So when that happens, you get an ambiguous with obtuse angle. This is much easier. There are only two cases. Okay, so here we'll explain why we get ambiguous. Okay, so same thing. We're gonna start with the door, right? The door will determine which case it will become, right? So let's make an angle then. Okay, so let's say the angle they give you is, let's pick something that's bigger than 90. Let's use 100 degree, right? 100 degree. And then the side, the hypotenuse side, which is this one. Okay, hypotenuse side, let's call this one, let's just choose a random number. Aaron, can you give us a random number?
8.
8, sure. Okay. So the case one is saying when the door, right? The door here, this is the door, is shorter or equal to the hypotenuse. Okay, let's write on the side. Door is shorter or equal than the hypotenuse. Okay. So what number would you pick then? Pick a number, Brendan. I want the door to be shorter or equal to hypotenuse.
4.
4, yes. Okay, 4 is shorter than 8, right? So 4 will be like half of 8. So that's a door. So if I swing, right, look at how I swing the side, right, the door. No matter where I swing it, it's never gonna touch the ground, right? It's never gonna make a nice triangle, right, with three sides connected. Because 180 degrees open really wide, right? You cannot change that. Okay, so this one, when the door, this one, the side A, right? Say side A is really short, right? Too short to touch the side, right? So then this one, you get no solution. And let's also understand why, how come equal to it also doesn't work. Okay, so let's say I make the door also 8. Now if I swing, it will lift up, right? It won't touch the ground, right? So it's impossible to make a triangle as well, right? So even with equal, it won't work, all right? So equal or shorter than hypotenuse. Next one is when the door is longer. Okay, let's write that down. Door is longer than hypotenuse. So we'll use the same measurement, right? 180 degree obtuse. And then the hypotenuse is also 8. Here's the angle. Here's the side. Now we need the door. Okay, so pick a number for the door, Colin.
9.
9, okay, so a little bit longer than 8, so 9, so maybe here. Now if I want to make a triangle, the only way for that to happen is to swing it and put it here, right? Then it will close up, okay? If I make it a bit longer, right, let's say 11, right, 12, 13, 14, right, then you can get something bigger. Okay, so you can use anything that's longer than hypotenuse, then that will work. Okay, here I've stretched it so it looks more clear. Let's say we make the door, that looks like what, 13 maybe. Okay, so this one you get one solution. So as you can see, if it's obtuse, it's much easier to determine the case. I don't care about the height. Okay, you just compare two things, door and hypotenuse, and that's it. Okay, and remember the equal sign is with the case 1. Okay, when it equals to hypotenuse, you also have no solution. Okay, so let's try a question down here. So you can see that the angle that I gave you is 120 degree, right? The 120 degree, so that's an obtuse. So let's draw it out, okay? Always put the angle on the left corner. So you either get no solution or one solution. So let's draw angle, right? Because it's 120, so do not make your angle like this. That's not 120 degree, right? So make sure your picture has to make sense. So here's the side. Here's about 120 degree. Okay, and then its door is the pair, right? A is 15, so let's do 15. Here's the 10, right? Side B is 10. Now because side A 15 is longer than 10, right? So we know this one should be stretching out. I think that one is too far. Okay, so let's change that. Something like this will make more sense. Okay, let's make this one shorter. Okay, so A is 15. Okay, and then, so this one will be angle B, this one will be angle C. So once you got here, then you can start to do the solving. Okay, we have 3 missing things, right? We have, this one is given, this is side, right? So the 3 missing parts, what are they, Eric? What are the 3 missing parts?
Angle B, C, and side C.
Yeah. So because it's unique, we just apply the sine law, right? Or one solution means unique. So you do it like your homework last time, okay? So we paired, write out the pairs, 15 to sine 120. And then you have side B, right? Side B is 10 to sine B. All right. And then you have side C, which is missing, and sine angle C. Okay, so once you get here, now this part, you can look at how you did this one, right? The left side, because this is one solution, right? So you just focus on, look at page question 14, the first triangle. You do the same thing, right? You got 3 pairs, right? You got 3 pairs. You are missing angle B. You are missing the pair for C. So you do exactly same thing as the part 1, the first triangle of the 2 solution. Okay, so you do the same thing. You use this, right? Find angle B. Okay, and then after that, you use the first pair with the last pair, and you can find the missing angle C. Okay, so we'll write that down. Okay, we're not going to go through that one again. So follow same steps of the first triangle in exercise 14. Okay, same steps as the first triangle on exercise 4. So basically this part. Okay, so the one on the left side. Any questions? Can you raise your hand if you understand? Okay, raise your hand if you understand what I mean by follow the same steps on the previous one. Okay, because we are going to move on to cosine law now, all right? Later we'll summarize everything together because this is a lot of stuff, right? Different cases, sometimes unique, sometimes ambiguous. Okay, but very lucky, the cosine law doesn't have any ambiguous, okay? So we can just apply it. So let's spend a little bit of time to show what cosine law looks like. Even though it's easier to apply, but the cosine law looks more confusing, right? It's much longer. Okay, here's 2 cosine law. So we use the cosine law when the sine law doesn't apply. If you want to use sine law, you must have at least a pair, right? For example, like here, you have 9 to sine 60. You must have a pair. So you will know that you can use cosine law if you don't have a pair. Okay, so you can write that down. When not given a pair. A pair means they give you an angle, not given a plane, okay? Given a pair. When you're given a angle and a side, that's called a pair. So if you are not given a pair, then you know you need to use cosine law. Okay, so what would they give you then? They will give you a side, and then another side, and then also give you an angle in between. Okay, so that's the side angle side. Or they can give you the 3 sides and not give you any angle. Okay, we'll talk about those 2 formula later. Right now we'll derive the formula first. So let me erase the yellow highlighted first. So the way to show the formula is we'll start with drawing the height. Okay, having the height, then we can have a right triangle, right? And once you have the right triangle, you can use SOHCAHTOA. Okay, I'm going to color it. You have the blue triangle on the left side, and then the red triangle on the right side. Okay, so first we need to put some label, okay? Because now you have a height. Let's create one point here. The point that the height is touching the AB, the side AB, let's call that B. Okay, any questions so far? This is the setup, okay? So now we'll first focus on the blue triangle, okay? So everyone look at the blue triangle now. We'll start with angle A, okay? So look from angle A, I want to write out a sine, okay? So step one, okay? Sine of angle A. Sine is opposite over hypotenuse. So which one over which one? Aaron? Opposite over hypotenuse.
H over B.
Yes, very good. H over B. Okay, so that's the setup. And then I'm going to isolate H. So B can cross multiply over, right? So B sine A will be equal to H. Okay, so just put that there. Okay, it will be in use later. Okay, next part I'm going to set up use the blue triangle again, but then instead of sine, I'm going to use cosine. Okay, so cosine A, right? Cosine is adjacent over hypotenuse. The adjacent, I'm just gonna call it AD, right? This one is the adjacent, A to D, right? So adjacent over hypotenuse. So same thing, I'm going to isolate AD. Okay, B cosine A. Okay, so far we got two things. Any questions so far? Anyone got lost? Okay, so once you get here, the next thing we're going to do is continue looking at the left, the blue triangle, okay? Because it's the right triangle, we can apply the Pythagoras. Pythagoras says a squared plus b squared equals c squared, right? A squared, b squared, c squared. So a is the AD, okay? So AD squared plus h squared will equal to b squared. Okay, can you raise your hand if you understand where this comes from? Okay, the blue triangle. The ABC, they are the AD, the H, and the B. Okay, and then I'm going to replace each one of them with the yellow highlighted, right? So for example, AD is B cosine A, right? B cosine A. H is B sine A. Okay, and then B squared just staying there. Is square each of them, right? So it will be B squared cosine square A, B squared sine square A. Okay, when you put a square beside the sign means the sine A squared, the whole thing squared. Okay, so I don't need the brackets. Now you can see each one of them has a B squared. So I'm going to make it look simpler. Divide everything by B squared. Okay, each on both sides divide by B squared. So you will end up with cosine squared plus sine squared equals to 1, right? B squared divided by B squared will be 1. Okay, give you some time to write this down. Everything here is just for preparation, okay? You might wondering, why are we doing this, right? This is just to get things ready. Okay, so when you finish writing this part, please raise your hand. Raise your hand when you finish copying everything so far. And then we're going to move on to the triangle on the right side, okay? Pretty soon. Okay, Eric, are you done writing?
I'm almost.
Okay.
Okay, I'm done.
Okay, now please look at the triangle on the right side, the red one. You also get the right triangle, right? So we could also make Pythagoras. So before we do that, right, the one on the hypotenuse is the A, right? This is the height. The one at the bottom is the D to B. Okay, D to B is part of C. Okay, remember the side C from the big triangle? This part, D to B. This is taking the C minus AD. Is that too confusing? Side C is the whole thing. Okay, let me use the green. Okay, maybe it's easier. Green part is the C. Okay, so if you take the green minus AD will give you DB. Are we good? Okay, so the green is the long one. Take away the left side, the AD. C take away AD will give you DB. So now we have three sides. Okay, so we are going to use the Pythagoras now. So Pythagoras says, we'll start slowly, okay? dB squared plus h squared equals to a squared. Let me flip it around, okay? A squared is dB squared plus h squared, okay? And then dB is C minus AD, right? So C minus AD plus h squared. Okay, I don't want to go too fast. Can you raise your hand if you understand up to here and also write everything down so far? Okay, raise your hand. All right, so AD, now you look at the yellow highlighted. Okay, look at step 2. AD is B cosine A, right? Look at step 1. The height is B sine A. Okay, so I'm going to replace AD and the height with step 1 and 2. Okay, so that's why we did those first. So C minus AD, which is B cosine A, square plus H. H is B sine A. Okay, you follow so far? AD is this one. H is this one, okay? All I did is replace it with step 1 and 2. We're almost done, okay? After this is just expanding and simplifying, okay? So I'm going to keep the a squared still on the left side, and then we'll expand the brackets, okay? Square the bracket, you need to do the FOIL. So square the first, minus, you need to double the two things multiply. So BC cosine A, and then plus B cosine A squared. So it'll be B squared cosine square A. okay? So that's the first part, okay? The first bracket will become this. The second part will become b squared sine square a. Anyone is confused about this step? Okay, you can raise your hand once you finish writing this part. We're almost done. Let me know if any step here, okay, because I did not expand slowly, I applied the formula. Okay, this red underline, after you expand, it becomes this. Okay, it's using the formula for a plus b squared. Okay, using this one. Okay, this is from the FOIL. Okay, and then we are going to simplify a little bit more. Okay, our goal is trying to get this formula up here. Okay, almost there. So next part, we are going to rearrange a little bit. Okay, the square, the one at the back, I'm going to take away the brackets, right? Because the bracket doesn't really matter. Okay, doesn't think, just take it away. So for the blue underline, because they both have b squared, right? So I'm going to factor the b squared out. So b squared will be on the outside. Cosine square a plus sine square a. Any questions? Okay, can you also raise your hand one more time when you finish writing this part? Okay, so the blue part is this part. Okay, after I factor the b squared, okay, that's what it looks like. Okay, Eric, are you copying?
Yeah, I'm copying right now.
Okay, let me know when you finish.
Oh, oh wait, I'm missing a part. Okay, I'm done.
Okay, so finally we have cosine square a plus sine square a over there, right? Which is our step 3. Please go back, look at step 3. We figured that when you see cosine square plus sine square, it will become 1. So this part just goes to 1. So b squared times 1 is just b squared. So if you rearrange, then you get our formula. B squared, you put the b squared at the front, plus c squared minus 2bc cosine a. So that is our formula from the top. Okay, so that's where it comes from. So what's the use of it, right? This one is used to find the missing side. Okay, so lowercase a is the side, right? So look at the formula on the top here. This is the side. Then you need to have an angle that's pairing with it, right? You must be given an angle and the other two sides. So what that means is if you have a triangle, right? You want to find the missing side. So this is the unknown. This one is the unknown. Then you must be given its opposite angle, right? So you can put it into the formula. And you also must be given the two sides that's beside it. Okay, so you must be given a side, angle, and a side. Then you can use it to find the missing side. Okay, and then I don't know if you still have space. Let's split down here. The formula on the right side, the one that has the side, right? This one, cosine A. This one is just coming from the left side. You isolate the cosine A. So to do that, okay, let me quickly copy it on the side here. I'm just copying the same formula on the left side that we derived. To figure out the second formula, you just swap, move this part, right? Because this one is minus. I'm going to move it to the left side, so it becomes the positive. This one, on the left side, I'm going to swap, move it to the right side, it becomes minus. Okay? So the negative goes to the left, the positive goes to the right. So you will get 2bc cosine A, b squared plus c squared minus a squared. Okay, they just swap place, and then both sides divide by 2bc. Okay, so 2bc will cancel out. So cosine A will equal to b squared plus c squared minus a squared over 2bc. Okay, so that's where the second formula comes from. Okay, so please raise your hand again when you finish writing this part. And then we'll fill in the blanks, okay? So we have b squared plus c squared minus a squared over 2bc. You see I boxed the letter A, right? That's telling you it's a pair. Angle A, if you're looking for angle A, you must put your side A at the back. So if you're looking for angle C, then the last bracket should be side C, okay? It comes in pairs. All right, so what that means is, I'll draw the picture down here. So this time, instead of finding missing side, we are finding angle A. Right, this is the unknown. So that means you need to be given side A, side B, side C. So the given is the three sides. Then you can use it to find the missing angle. Okay, then you find this one. Okay, this is the unknown. Okay, so that's the two different formula, but actually come from the same one, right? So try the question, okay? Two questions, one is for finding the missing side. The other one is find the missing angle, okay? Then that will be all for today. And then we'll make a summary, okay? For both laws. So here we have triangle PQR. Let's draw it out. We want to find side R. Okay, so let's draw the picture. We'll draw the same way that we learn, we have in the picture up there, right? So the missing side R, we'll put it here. This is the missing one. So that means across, this is the R. That should be the given. And then the other two sides you can put anywhere. It doesn't matter. You can put a P up here or down there. It doesn't matter. Okay. The location for P and Q is fine. It's 70. Okay. So this is the unknown. These are the three given things, sine, angle, sine. So all we need to do is just fill in the blanks. Okay, so you look at the formula, a squared, right? A, B, C, they are just location, okay? So you just remember the A and A is a pair. So in this case, it's the R and R, all right? So draw the blanks first. We are looking for R, right? So we put R there. All right, so I'll let you guys fill in the numbers. When you finish writing the numbers in the brackets, please raise your hand and we'll check. The order that you put P and Q, it doesn't matter, okay? Does anyone have trouble filling the numbers in brackets? Let me know. Okay, raise your hand once you got the number in the brackets. Okay, Yosher, can you tell me starting from the first bracket, what number?
R squared equals to 15.3 squared plus 24 squared minus 2, 15.3 times 24 times cosine 70.
Yes, very good. Okay, so the first thing I will fill in is the 70 degree, right? Because that's the pair with the angle, with the psi r, right? Psi r and angle r. So now all you need to do is just type in everything on the right side into your calculator now. Okay, so everybody please try it. You will get a number that's bigger than 500. Okay, so raise your hand once you get the number. Okay, Brandon, what number do you have?
I got 558.9.
Yeah, very 158.9104. Okay, because it's not the final answer, we'll try to keep at least 3 decimal place. And then to get an R, you just square root that number. Okay, so that number will be what, Colin?
23.6.
Yeah, thank you. 23.6. Okay, so final answer, you can do the rounding. Okay, so that is your final answer. Now let's look at last one here. We have triangle PQR. Okay, so let's draw the picture out. So instead of finding the missing side, we want to find the missing angle, right? Angle P. So the angle that we want to find, we'll put it at the corner here, angle P. Right, this is the unknown. So that means they have to give you the sides, right? So the pair, you have to put it at the opposite. The other two sides, doesn't matter. You can put the Q anywhere, right? You can put a Q up here or down there. Okay, so remember the pair you have to put at the right place. This one is the Q. This is the R. Okay, so you are given psi, 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 and then you are finding angle P. So this time you will be using the second formula. Okay, so it'll be cosine P. Okay, so same thing, you fill in the brackets. Remember which one goes where, okay? The key one is the one that's at the back. Okay, so let you fill in the blanks. Please raise your hand when you got everything in the brackets. Okay, Eric, can you tell us what goes inside the brackets?
I think it should be 11.4, 12.5, 10.3, and then on the bottom it's 11.4 and 12.5.
Thank you, very good. Okay, 12.5. So remember the 10.3 is the one across from the angle you want to find, okay, the P. All right, and then now we need to type in everything on the left, on the right side and get a number, okay? So raise your hand when you got that number. Should be 0 point something. Please keep 3 decimal places because it's not the final answer, okay? We don't want to do the rounding too early. So 0 point, Aaron, what do you have?
0.632.
Yep, thank you. And then to get angle P, we do the inverse of 0 0.632. Okay, this one. What do you have then, Brendan?
Yeah, hold on.
Yep.
Okay, I got 50.8.
50.8 is correct. Okay, very good. All right, so we finished our sine law and cosine law and the whole trig topic. Okay, it's a huge topic. Sine law, cosine law is quite confusing. Okay, because sometimes you get unique, sometimes you get ambiguous. Okay, so I created a roadmap, a flow chart to summarize everything. So when you review, you just go through the flow chart. So let's go back up. Okay, everyone got this part? Okay, let's go to page 1. Not page 1, sorry. Where is we? Oh, not page 1. Page 15. Okay, this is a summary. Sine law, cosine law flow chart. Okay, on number 7. So when you are given a question, okay, if it's not a triangle, then you think about a flow chart, okay? Because sine law, cosine law, you only use it if there's no right angle in the triangle. So first thing is you check if you are given a pair or not, okay? So you can write it down, given a pair. And you put a question. okay, given a pair. So if you are given a pair, if it's yes, then it's sine law. Okay, then you know you need to use sine law, right? Because sine law you need to have a pair. If you don't have a pair, right? If it's no, it's cosine law. Okay, that's the very first question. Whenever you get a triangle that doesn't have 90 degree, okay, you look for pairs. Once you get to sine law, then you need to think about, is this one unique or ambiguous? Okay, so if it's ambiguous, it must be an ass, right? Ambiguous means a pain in the ass, right? Very difficult to do, a lot of things to think. So you ask yourself, do you have an ass? Okay, that's a weird question, but it helps you remember. Okay, so is it given ass? Okay, so write that down. Okay, given ass. Okay, so if it's no, then it's unique. Okay, and if it's unique, you just apply the sine law. Unique means only one answer. Okay, apply sine law. Okay, then you just get all the answer. If it's yes, right, you have an ass in the question, then that means it's ambiguous. Okay, I want to stop here for now. Okay, can you raise your hand when you finish writing the picture so far? Okay, once you get to ambiguous, then that's the part you think about the cases. But remember, we could have acute, we could have obtuse, right? So if it's acute, then you have 4 cases, right? If the angle they give you, right, the ass, right? If they give you an ass, then it's ambiguous. Ambiguous, you could have acute, you could also have obtuse. Acute, you have case 1, case 2, case 3, case 4. Case 1 is when the door less than height. Case 2, when the door same as height. Case 3, when the door is between the height, right? Longer than height, but less than hypotenuse. Last one, when the door is longer or equal to hypotenuse. Okay, any questions so far? Okay, raise your hand when you copy everything to here. Yeah, if we don't organize like this, okay, it will be too much to remember, right? You can see the big picture if you have a flow chart like this. So this is also one way you can study, right? When you are moving on to harder subject, right? Try to organize, look at the big picture. Now you get obtuse, you only have 2 cases, okay? Oh, also we forgot to write the solution, right? So this one has one solution, no solution. This one has 1 solution. This one has 2 solution. This one has 1 solution. Okay, and then obtuse only has 2 cases. One is when the door shorter or equal to hypotenuse. This one, when it's longer than hypotenuse. Shorter, too short, right? So no solution. Longer, you only get one. Okay, that's the new thing we learned today. Now cosine law doesn't have ambiguous, so you just have two parts. Find the side, okay, or you find the angle. Okay, if you are finding the side, then you use the formula with a squared equal blah blah blah, right? If you want to find the angle, then you use the one with the other formula, cosine a equals to a fraction, right? This one. Okay, so that's the summary of our sine law, cosine law. And then you can look at the previous one, the one before, right? 1, 2, 3, 4, 5, those summary, okay? And then compare with the notes. Okay, any questions? Can you raise your hand if you got everything down? All right, so that will be all for today. And next class will be after the winter break, okay? I think it's January the 9th. And remember, tomorrow you have to go to Palmer to pick up the book too, okay? So if you have any question, you can stay after. And have a great weekend. Bye-bye.
Bye.
Bye-bye.
All right. Thanks.